Hi there. Thanks for joining us this afternoon. Glad you can make it. We're here to talk about the launch of SDE, which is the Spicule Data Engine. I should introduce myself. I'm Tom. I'm the director of Spicule Limited, and we deal with data problems. Our background largely has been in the data sector for the last decade-ish, and so we like to be able to solve problems using data, enlightening businesses, and trying to make their lives an awful lot easier. In doing so, over the years, we've come across a whole multitude of problems, and currently in our work with NASA and DARPA, we deal an awful lot with big data and indexing-based solutions, like Google Search for Enterprise. And so what we're trying to do with SDE is bring that experience and that knowledge from Google and from DARPA and bring it into the business world. And we think with SDE, what we're bringing to the table here is something that we can actually leverage pretty well in the business world to give flexibility when it comes to deploying data systems, scalable data systems, and doing processing at high volume. So what exactly is SDE? The Spicule Data Engine is at its core an open source big data platform. We believe wholeheartedly in supporting the open source ecosystem, and we think that in doing so, it will benefit the data world at large. We can give back and we can help develop new tooling to help deploy, make life easier, for people who are using the big data platforms. What we're bringing is cutting edge data processing to the masses. We're trying to make it easy for people to deploy, easy for people to scale, and easy for people to work with. So let's take some real world examples. Hospitality. Hospitality has always been a minefield with business, and it's something we have direct experience with at Spicule, where we're trying to solve people's problems. Utilizing data efficiency in the hospitality and retail world isn't done very often. It's not necessarily about leveraging the data that you have at hand. Hitting targets is one thing, but actually it often feels like people are making a blind guess. And so, using SDE, we can offer more accurate forecasting. We can help people paint pictures with data and get to the meaning of those answers. And this is leverage the power of SDE to bring that to your desktop. So how does SDE differ from the rest of the world? What we're trying to do is really bring like best of breed applications and tooling and turn it into a reality. We've mixed what pre-existing software, pre-existing charms they're called. We'll get onto that in a bit. And adding in a bit of our own special sauce, and then we're adding support, maintenance, to the stack, and that's come together as the Spicule Data Engine. How do we differ? We have unique aspects in terms of flexibility, scalability, and our support. Our background being data professionals means that we can offer additional insight on top of what a more traditional big data company would be able to do. So, and we can then leverage SDE to run in a multitude of different places. If you want to deploy it locally, in your own data center, not a problem. If you want to run it in the cloud, not a problem. If you want to run it in containers, not a problem. Or a combination of all three, absolutely ideal. We also try and make pricing as simple as possible. We ensure that the support costs are defined up front. It's pay per minute and not pay per year, so there's not a massive upfront outlay. SDE is literally pay as you go. And you can also define your own level of support, which means that you can scale up and down relatively straightforward fashion. Our support team are ready and waiting 24/7, 365. And so if you have a problem, we will move heaven and earth, get it resolved. Updates and upgrades can be deployed on your behalf by us. And we love to solve complex problems. So, if you want to leverage SDE to get your data manipulation started, then give us a call. So I'm going to dive in now and go through a bit of a presentation we've prepared. And so hopefully, if I share my screen. So we're going to run through what's inside SDE, makes up the stack, how it's deployed, and then go for a bit of a demo, a bit of a walkthrough, and then wrap it all up at the end. So what's inside SDE? I was mentioning that we're trying to bring best in class across the board to the data platform. And so, this is a big data platform. I don't really like the word big data. I prefer unstructured data. I think it's more, in tune with what we're trying to do. You don't have to have masses of data, but Hadoop is good at processing large volume of unstructured data. What we're bringing is Apache BigTop. For those of you who haven't heard of Apache BigTop, it's the official packaged version of Hadoop. It's tested on a bunch of architectures. It's released by the Apache Foundation, and so it is as close to the real deal as we can get in a deployable format. And so, BigTop really is where it's at when it comes to Hadoop processing. It will allow us to deploy a stable system onto all these different platforms pretty straightforwardly. And then we're going to bring on top of that, we're going to bring in data processing. So, still at the forefront of this at the moment is Apache Spark. Of course, this may change and we can flex with it, but Apache Spark is used all over the place for high performance data processing. What does Apache Spark bring? It brings improved performance. MapReduce on Hadoop by itself is pretty slow. And so using Apache Spark, it will allow us to, allow end users to process the data in a more timely manner. We also are able to write code in multiple languages using Spark. You can write in Java, Scala, Python, R, and a bunch of other things. So it allows people to integrate more seamlessly with their applications, to run against a multitude of different data sources. S3, HDFS. So on top of that, what we're going to bring in terms of data federation, getting data out, combining it with already existing data sources, and certainly top of the list there for us currently is Apache Drill. For those of you who haven't come across Apache Drill, a SQL engine of sorts for NoSQL data sources. Connect to Hadoop, again, HBase and S3 type data sources, but you can leverage that with a traditional database like MySQL, or take it straight out of CSVs or Parquet files. That way you can start combining lots of different data sources without them actually being together in a single place. It also allows you to use JDBC drivers to connect to Drill. So if you have a third-party application, data visualization application, your in-house tooling that uses SQL as an interface, Drill allows you to use SQL over the top of these data sources or combined data sources. Column store optimizations for improved performance. Of course, big data, being big data, is generally sluggish, and so using Drill to speed these things up. There's the REST interface for application access, which will allow applications to interact with Drill without actually having to write SQL. You can use the JSON data format to pass data back and forwards. So another thing that we wanted to add to the stack was data security. This is part of the stuff that we're bringing to the SDE platform that will allow users to lock down their data in a more efficient manner. And so data security using Apache Ranger will allow us to secure your Hadoop cluster out of the box, but also if you're using Solar and a bunch of data-related products, you can put Ranger in front of it. Then you can connect it to your existing corporate ldap or more likely Active Directory server, which means that obviously then users can log in using their corporate credentials, and you can centralize the auditing and the administration of data access on your Hadoop cluster. So Apache Ranger, the direction we're heading in data security land. More to come on that, but we will circle back to that later. Best in class for monitoring. So monitoring, of course, is something that's often forgot about when dealing with data systems or data platforms. But we want to make sure that monitoring is something that's key to and core to everything that we do, to make sure that our platforms are as optimal as possible. And so we've got Ganglia for Hadoop stats. Ganglia is cool because it scales up really well. You can deploy Ganglia across your entire stack. If you've got 100 Hadoop nodes, not a problem. If you've got 1,000, equally not a problem. We can also use Nagios for host-based monitoring. We can make sure that the systems scale smoothly in a way that's going to work well for our customers. Want to bring decent business intelligence tooling, best in class of BI. There's an awful lot out there these days, and so we want to bring some of the more effective applications to the stack. We'll speak in SQL, which is why we've got things like drill in place. You'll be able to visualize data using open source ldap technology, create custom dashboards, execute queries across the entire data source, as opposed to being a single, subset of data. We can run batch reports for offline streaming, and also for data transformation. It's one thing putting unstructured data into the platform, but there's always a requirement for getting the data back out. And so, having a decent data integration tooling and integration into the stack as well is something that we're working hard to make sure that our users will be able to leverage effectively. Often much nicer than writing code by hand. Some of the use cases, some ideas for SDE. So, what can you use SDE for? Where is it going to be effective in business? One of those areas, of course, is retail analytics. Process both archived and real-time data. If you need to know stuff that's coming out the tills of, across the globe in real time, you can stream that stuff into SDE and start getting the data out the far end of it. You can store the slow-moving data within Hadoop in HDFS. You've got it there forever. It will, scale itself out, and you'll have a large volume of historical data, which is great. And predictive analytics. Sales in the custom dashboards, again, using the BI tooling, visualizing sales information and some of the stats would be absolutely ideal. And process data in real time using Kafka. You can stream that data into different tools to make sure that it's available to different users at that point in time. Another idea would be a recommendation engine. You can leverage machine learning. Machine learning is hip, it's cool, and it's absolutely where it's at. You can leverage machine learning with SDE to make sure that you stay ahead of the game. Fields into the engine from the internet feed, sorry. If we've got different data feeds coming in, we can stream them in directly into SDE, leveraging that data locally. And then you can output the data into Hadoop and then use Hadoop's power on top of that to process a large volume of data, get it transformed into a way that you want to be able to report off it, and use it further in your application. Another idea, cybersecurity analytics. It's another big thing, especially with the way the world is currently. Streaming network traffic into Hadoop means that you can then use Spark for processing event-based data. Use machine learning for enhanced detection. If there's trends and stuff that you can teach machine learning model, then SDE can absolutely help leverage that capability. Logistics optimization. So getting products from A to B can often be an interesting challenge for businesses. And so, optimizing the routes they take, when they travel, when drivers rest, the loading and unloading times can often be a great way for companies to save money. Take Amazon's recent purchase of American Whole Foods. Their first port of call is to optimize the warehouse process because it's somewhere where they can save money. And so logistics optimization is absolutely key to a business saving cash. So SDE can help you stream real-time logistics data into a platform that you can then process events using Apache Kafka. Again, you can post-process the data using Spark, using a bunch of different tooling to help optimize that data and provide valuable insight into what's going on in real time. Also then, use a bunch of different tooling, but here is in our example is Spicule Analytics to be able to extract that data and then display it in a visual format on maps and charts and stuff, so that users can understand what's going on. Lastly, in this section, the idea of image processing, and this is something that's key to what we do with NASA, and allows us to crawl different locations and ingesting image-based data. Image processing is a big business across the world. And so, using machine learning to categorize images, improve from their mistakes, output that stuff to HDFS, and then, process it further is a great use case for SDE, and it's used, in a bunch of different industries. So there's some ideas for, high-level ideas for what SDE could be used for. Of course, there's going to be an awful lot more. This is just a few of them. So, hopefully that sort of whet your appetite a bit. And we're going to move on to deployment options. How do you deploy SDE? Where can it go? Is it, software as a service? Hopefully we'll answer a few of those questions. So SDE itself, we can deploy into a bunch of places, be it on-premise, in the cloud, in containers. If you have already a server farm that's available to you, then manual deployment is the slowest, but is certainly one way of being able to deploy it. As long as you have SSH access to a bunch of Linux servers, you can deploy SDE to your business. Well, MAS is a metal as a service and will allow you to install SDE onto a bunch of bare metal servers without a great effort. MAS will manage those servers for you and make sure the right operating systems are installed, networking is configured effectively, that type of thing. And at Spicule, we can certainly help with that MAS setup and configuration. And then after that, it should just about run itself. Of course, these days, one of the best places to deploy software is in the cloud because of its flexibility, and that can be public cloud or private cloud. SDE will support AWS, Microsoft Azure, GCE, OpenStack, and a few other clouds. And of course, if you have a specific requirement for a different cloud that's currently not supported, we can certainly look at recommending support for that type of stuff. Finally, in the deployment options is container-based deployments. For those of you who live in the land of Docker, there is also Lexi and LexD-backed containers, and those containers will allow you to deploy services to them. So SDE can certainly leverage that technology and deploy itself to containers. Ideally, this is more ideal for prototypes and demos, but you can also scale up to large-scale deployments as well if the need requires. And of course, with the whole thing staying containerized, when you tear it down, it goes away, and you're back to having a clean slate. So also, for a development environment, typing, the container-based deployments for SDE is ideal. So also back at the start, I mentioned support. Support is key to what we offer our customers and clients. And support also scales with the deployment. It's not a fixed upfront cost. It scales as your deployment scales. You can also select the level of deployment, second or third line support depending on your own requirements, and you can swap and change that as the need fits. You can select different support levels for different components, as opposed to everything being like third line support or everything being first line support. You can vary that, and it flexes depending to different levels depending on requirements, as I mentioned a minute ago. The support is certainly flexible. It's phone-based or email-based. You can obviously do on-site stuff, should the need arise. And so if you have any problems, you can just give us a call. So it's straightforward. We wanted to make sure that pricing was pretty as easy as you could get. Nothing hidden under the hood. Wallet-based system, you pay for what you use. As you deploy stuff to your environment, the wallet will start deducting funds from your account. When the account starts to get empty, you top it up. And that, again, scales depending on the units deployed. And as I said earlier, it's like and so that will vary up and down depending on what you're trying to achieve with your deployment at that point in time. Pricing reflects like our desire for a scalable system, and literally you pay as you go. So what we're going to do now is flip through into a bit of a demo and explain how SDE holds together. And then hopefully you'll get a better understanding for the application, the platform, and how it's deployed. First thing I want to show you is the default bundle, which we've been working on. And if I you can see the different applications that make up this bundle, and they hang together and assign relations to one another. And the cool thing about the bundles is you can deploy this entire stack with one command. Like literally one command, you can deploy. I think it's about 15 different services and components, wire them up, and there's not a single line of code involved, which obviously makes it very flexible. It means we can deploy this type of stuff to the different cloud models, without actually changing any of the underlying code, which is great for system maintenance and upgrade and support, and also if you want to swap to different services, different cloud provider or whatever. So that's the bundle, and then what it looks like in reality, if I flip over here, is zoom back out. So as you can see here, we have like the SDE demo bundle up and running, and this is made up of a number of components, and we've tried to organize it in a way that flows well for people who don't understand necessarily how the Hadoop stack hangs together. So on the top left, we have Ganglia, which is our monitoring. Ganglia is up there doing its thing, and that's monitoring the Hadoop stack for us. And so here in this triangle, you can see that we've got 5 yellow elephants, and the yellow elephant is the Hadoop logo, for those of you who don't know it. So that's the Hadoop stack up and running. Although you might have multiple units, it doesn't necessarily display it on the screen itself. And you can see here we've got 3 agents that are up and running, and they provide the computational power for the Hadoop stack. The way that we deployed it using Juju is the fact that if suddenly you decide that you need to deploy 5 or 6 workloads and you need more processing power, all I have to do, or you have to do, is tell it to scale the application, tell it how many more units you want, and tell it to go and fire those up. If it's in the cloud, it'll just go and commission new machines, it'll scale it up, and that's all you have to do. The relations will take care of the rest of it for you. We've got Apache Ranger. Apache Ranger is the security module that we use, and that hooks into Hadoop. And then in our example here, we've got an LDAP connector. Now, we appreciate that most businesses will already have their own LDAP up and running. And so to deploy this stuff in a way that will allow users to hook into their existing authentication mechanism, we're creating a bunch of different connectors, the LDAP being the first, to allow them to connect to an existing authentication module. We also have an open LDAP module as well, so if you don't have a central authentication system but you're interested in deploying one for your business, we can deploy an open LDAP server as well. So moving on further down to the right-hand side, we've got Apache Spark and the processing stuff, so Kafka and Pento data integration. So they're like our 3 processing modules that will allow you to stream data into or out of the platform and transform it as it goes as well. And so that's how we do the data manipulation. Finally, on the right-hand side, we have our different UI tooling. So, of course, the idea with this platform is it's pick and mix and mix and match. It's not a set definition in terms of what software you deploy. So, in this example, we've got Apache Zeppelin, we've got Seiko Analytics, and we've got Apache Drill sat there waiting. Of course, in reality, you probably wouldn't use Zeppelin and Seiko. You'd pick one or the other. And we've also got Pento Business Intelligence and a few others kicking around. So you can really pick and mix your user interface, but you wouldn't necessarily have loads of them deployed at the same time. But in this demo, we've brought a few extra up. So, don't feel compelled to keep all this stuff running. If we want to shut things down, we can just select it and remove it from the model, and the machine will go away. This is, some of the great flexibility that Juju really brings to our deployment. Anyway, so this one is deployed in AWS. So this is all running up in Amazon Cloud. If I select a charm, I can see how this is configured. I can then select the expose and see where I can get access to this. Through a few of the different user interfaces and just show how it's currently up and running. So we'll start with the Hadoop stuff. And the name node is really where all the useful information comes from. And so when I go into the name node UI, I can get an overview of the system, how many are up and running, and then obviously storage information. It's a big data system, so we want to have plenty of storage. Capacity is used and how much is remaining in the distributed file system is normally quite a useful thing for people to know. The other thing as well, of course, is the amount of live nodes, the amount of dev nodes. It's designed to be a platform that is fault tolerant and can deal with failure. And so if you've got dead nodes, it's often useful to know about them, although Ganglia should already let you know, so it shouldn't be too much of a surprise. That is the name node information. Again, I can have a look at the different tabs within this. I get data node information, snapshot information if I have snapshots, and so on. That really is the guts of the Hadoop system up and running. If I then want to look at Spark, so Spark provides me with data manipulation and data processing capabilities. And again, at the top level, there's a couple of different screens here, but at the top level, I can see what running applications I have, different servers I have. So if I wanted to spin up a Spark cluster again, I could just tell SDE to scale, and it would scale for me and create new workers and enhance my Spark cluster. And so, so I can see what running applications are sitting around in there. And of course, what I want to know is what sort of load my system is under. And so if I look at the Ganglia, or, again, I can see here exactly how Spark is behaving, the memory consumption, the CPU load, and that's across the board as well. If I navigate back up, I can see the load for everything over the past hour. And of course, as your cluster gets older, the more information you get, the more useful Ganglia becomes. It gives me a great overview about the state of my cluster, whether I need to scale it, whether I've got too much capacity and I actually need to switch stuff off. Ganglia is ideal for that type of thing. So I can then flip to Zeppelin. So if people haven't come across Zeppelin, I'll probably get told off for it, but if people have come across IPython, or what's now known as Jupyter Notebooks, Zeppelin is very much similar, but instead of being Python-based, it's largely Java and Scala-based. And the idea being that you create notebooks for data analysis. You can enter Markdown, as you can see, to get Markdown information. You can then write stuff using Scala for Spark integration, and so I can start writing Spark programs within Zeppelin. Of course, that's much nicer than having to open up a shell and use the terminal to be able to interact with Spark, especially during the prototyping phase. You might end up writing a library around it, but for the prototyping, then Zeppelin is a cool way to go about it. But it's also a good way for you to be able to share information with a bunch of different data scientists as well. And so Spark in itself is a very useful to run. There we go. You can see, it's just run my very simple notebook, which prints out some Markdown, a whole program, and if I stick it into report mode, you can see how it just prints out useful information. So if you had a notebook that you wanted to show end users, you can embed charts and tables into this type of thing, and then really show the capabilities of your big data system to management within the business, for example. The other thing as well is Spicule. So Spicule is an open source OLAP browser written by our sister company, Meteorite BI. And what Spicule allows users to do is slice and dice data. It's usually time-based stuff, but that's not mandatory by any stretch of imagination. It's ideal for business users. You don't need to know how to write a query. You don't need to know any SQL. And so if I, for example, create a query that says, show me all the unit sales by city, you can see here that I have a big long list. Visualize that and start searching subsets of my data to find trends within my data. If I would then want to show it over time, I can say by quarter. See obviously how the chart reflects all this type of slicing and dicing to really offer insight of your data to end users without having them to obviously learn how to write queries for big data especially, but even SQL. SQL isn't something that comes naturally to the business users, and so allowing users to just interact with the data is a great way for users to actually learn learn what's in the system, ask questions of the data that's in the system, and really discover what's available to them, which otherwise they may not. So that's the system at a high level. What I want to show now is, just stop sharing that screen. So what I want to show now is just a little bit of data that we put in just to show how it sort of flows through the system. So if I share my entire screen. So on this window here, you can see how I have a terminal, and I will zoom in. And in this terminal, we have a file that's called WA Retail Sales Marketing CSVH, which is a CSV file that has pretty bog standard marketing data in it, sales of stuff over time. It's literally a CSV, there's nothing special about it. So we have that on our name node. And so what we're going to do now, I did earlier, sorry, is we put that file into HDFS. And so if I run ls on the right folder, try again. So I did, there we go. If we run ls, you can see how that file has been imported into Hadoop. So it's within the Hadoop HDFS cluster, which means obviously we can now leverage the tooling that's set up with SDE to be able to start analyzing data with that. So one of the more obvious things that users might want to do with a CSV is it's tabular, is get that information back out. As you can see back into the model, here's my Apache drill. It's connected to Hadoop. So that means I can use Apache drill to start slicing and dicing that data. So if I look at Apache drill, that one, I can then take an SQL query, which is simply select my fields. And you can see here, instead of selecting a table, I've got marketing CSVH. I've done nothing apart from put this file into Hadoop, but then if I hit the submit button, you can see how it started extracting that data, and that's all the fields in there. And similarly, if I decided I just want year and product line, maybe unit sales price. Again, so I can start interacting with this data, and of course, this is like a smallish CSV file, but this could be gigabytes of data. There's no reason why it couldn't be. So if you've got data streaming into your platform that's in a CSV type format, you can have users instantly start interrogating it. And as like I said earlier, JDBC driver, so you could hook up Seku or Zeppelin or your favorite Tableau or whatever BI tool you use internally directly to SDE to start leveraging that data. If I go back and then look at this one, so another thing that you can do is CSVs inherently are reasonably slow. Column store optimization, there's nothing you can do to make it faster. And so what we have also, what Apache Drill also allows you to do is transform CSV data or data in a different tabular format into Parquet file formats. And Parquet is it's a column store data format, file-based column store data format. So for those of you who know Amazon Redshift, who know what used to be Infobright, VectorWise, Exasol, the column store databases that are used for high-performance analytics, Parquet sort of offers that within a Hadoop context. Tell it to take CSV files or whatever you want and output them as this file format. And what that means is that you suddenly have a high-performance column store database format in your Hadoop cluster. And so I've made that mistake I did earlier of forgetting to limit the rows, but we're going to return back the entire Parquet file to the UI. But so what that allows us to do, if I go back to the HDFS, in this sales data directory, you can see there's only one file in there. But if you had a large volume of CSV-based data, something that you wanted to optimize, you can tell it to export that data to the Parquet format and then use Drill to instantly access that data. And again, I've set this up. I've done whatsoever. Just the relations and the model itself within SDE has allowed me to connect these things together and then start writing queries over it instantly. And again, Apache Drill supports a bunch of different stuff. So Hive and HBase, we're going to start leveraging with SDE. S3, you can start querying S3 data directly, and a lot of businesses store stuff in S3. And again, it's codeless. So, in doing so, this allows us to start really leveraging the flexibility of SDE, but without having to have in-depth technical knowledge about how to set all this stuff up, because this is what SDE does for us. Hopefully, that gives people an insight into how SDE works. And so, I think to the masses really allows businesses to start leveraging the data they have at hand, really start being effective and asking more important questions instead of what data do I have. It's like what's inside this data, how can I optimize my flows, my processes, make more informed decisions, rather than just muddling through on a day-to-day basis. And again, if you already have an optimal data flow or something that's in place that you feel that is effective, maybe SDE can just bring a little bit more to that platform just to solidify what you're already doing. So there we go. Hopefully, the overview of SDE has been of use. Hopefully, people understand what's going on and where we're coming from. Next few weeks, we'll be releasing a few different videos, features, tutorials, how-tos about how to leverage SDE, how to use it. If you're interested in trying SDE, then head over to spiculedata.com spicule.data.com and then enter your email address into the early access box. And as soon as we have stuff that's available for end users, once we get through a few more tests, we'll start onboarding people, and they can take it for a spin, and you can obviously let us know what you think of it. In the meantime, thank you very much for watching. If you feel like you could make use of our services, feel free to head over to spicule.co.uk. Have a whole host of different services, data related or not so data related, that we can offer you in terms of systems deployment and systems automation. We'll see you again soon.